Okay, so we're in section 4.5. We're heading into the second half of this chapter in algebra. And we're using a very favorite form for graphing lines, linear equations. And in 7th grade, I didn't just call it slope-intercept form. I added a little detail to that so that you could always think of it, what intercept we're talking about. So let's say it the way that I said it in 7th grade. It is slope
y-intercept.
That's right. It's the y-intercept. Because there are two intercepts, I wanted it engraved in your brain that it's the y-intercept that we're given in this form. And so let's say the form together, those who remember it. Ready? Y equals
mx plus b.
Right, there it is. Slope y-intercept form. So the beautiful thing about this form is if you put your equation into this form, right there popping out at you are the two critical things you need for graphing. And so if we look at them in the order that this little name is, slope and y-intercept, then the first thing we see is the m. M, like the mountains, is the slope. It's the slope. That number gives you the slope. Sometimes it's a fraction. If it's not, we know the denominator would be 1. So we could turn any number, integer, into a fraction, or even any rational number into a fraction. Okay, so we have the slope, and then there is a number, some constant number, sitting just to the right, and that is the
Intercept.
What intercept is it?
Y-intercept.
The y-intercept is there. Okay? And these other two letters that you see in slope y-intercept form are x and y. It's actually, y shows up first. Y is isolated, right? But x and y together are what?
Variables.
No. Raise your hand if you have an answer. X and y together make a what? A point. And so they represent all of the possible points that could be found on this line. Do you understand? Do you see why it's left open? They are left x and y because they represent together all of the possible solutions for the line. A point on the line is the x and y. It is a solution of the equation. On your quiz on Friday, I asked you to give 2 solutions to an equation. And most people did quite well there. Some people didn't know what to do there. Again, you were given an equation that the only things missing were x and y. So it might be like this equation here. And if you have that equation there, could you find 2 points? We were making tables all the last few weeks. And you could just simply find any 2. Okay, so we're just going to look at a couple of equations and identify the slope and y-intercept. So as I look at this equation here, what might we do to it? I mean, actually, does anybody remember the form this is? This is x plus 3y equals 9. That is what, right? Standard form, very good. The ax plus by equals c type of form, standard form. This is not slope-intercept form, so the slope and the y-intercept are not popping out so easily for us. We want to transform this into slope-intercept form. And slope-intercept form has what sitting all by itself on the left side, everyone?
Y.
The y. And so it's just the same as our function form, remember? Where we have the y isolated on the left side. Okay. All right, so who's going to help me transform this into slope y-intercept form? What do we do? Faith.
Subtract x from both sides.
Subtract x. And now tell me what we have.
3y equals negative x plus 9.
Notice she's keeping the x term closer to the equal sign because that's what slope-intercept form has. So.
And divide by 3.
And what do you divide by 3?
Because I have negative x plus 9 divided
Like the whole thing or each?
by 3.
Divide every term by 3. Good job. And we have y equals
Negative x divided by 3
Okay, so we need to find both the slope and the y-intercept. It says identify them, and so we'll use the variables that are used in slope y-intercept form. So this is a little trick. I mean, the easy one right now is the y-intercept, right? What is the y-intercept, everyone? 3, there it is. All by itself, 3. So this graph has a point at 0, 3 on the y-axis, 3. And then the slope is a little trickier to see. What is this fraction that we have here? When you have a variable with no number in front of it, what is the number? 1. I have -1 here over what? Over what? 3. So the slope is -1 over 3. You see that? Okay, let's find the slope and y-intercept here. And if you're watching this on video, pause it and come back and see the answers. Anybody want to do it? How about number 1 though? This is so easy, I don't even need a volunteer. It's already in the form we like, right? So can we say this together? The slope is? And the y-intercept is? 3. It's in slope y-intercept form, so that was easy. How about number 2? Okay, Nico, tell us how we're going to transform this.
First, I would minus 3y to both sides.
Minus 3y. It's already
3x.
negative, do you see that? So that wouldn't remove things, move things. So if you subtract 3x, that would move that. And what do you have left?
You have negative 3y equals negative 3x plus 12. Then I would divide by 3, negative 3 to both, to each one.
Divide every term by -3, and you get?
I would get y equals 1x plus negative 4.
Which we could say is x minus 4. Okay, so the slope is,
The slope is x, or
what number is in front of that x?
1,
1, so the slope is 1. And the y-intercept is?
negative 4.
Good, and I like how you're bringing the sign along with the y-intercept. And how about number 3? Anyone want to come up? And, okay, then tell me from where you are. Casey.
Subtract x. This is 4y minus negative x plus 6. And then we divide by the you get y equals negative x over 4 plus 3 over 3.
So the slope is
Negative 1/4.
-1/4, and the y-intercept is
3 over 2.
3 over 2. Okay, very good. Questions? Okay. Then let's graph using this form. So the equation is x plus 2y equals 4. Brandon, help us.
Okay, you would minus the x from the 4. You would have 2y equals negative x plus 4. Then you would divide 2 from each. And it would be y equals negative x over 2 plus 2.
And so what is the slope?
The slope is negative x over 2.
Actually, I need numbers, no x's. What number comes in front of it?
Negative 1 over 2.
Good. So -1 over 2, and the y-intercept is
2.
2. Okay, so good. We have the two things we need. This is enough to graph, isn't it? Do we have a point? Yes, we do. What point do we have? We have the y-intercept. I don't hear you saying it, but we have the y-intercept, right? So again, the y-intercept is a point on the y-axis. We just start at 0 and we go up 2. There it is. It's a point. And now we use that point as the starting point to find a second point. All we need are 2 points to graph a line. If we do this correctly, we have the perfect line. Okay? So we will start there at this y-intercept, and we will use our slope. Okay? So slope is, give me the R words. Slope is what over what? Rise over run. So how far are we gonna rise?
1,
-1. We're gonna go down 1, and then we're gonna run, what?
2.
+2. Down 1 over 2, and there's a second point. So our slope is -1 over 2. We could also write the slope as 1 over -2, right? Let's try finding a point that way. So instead of rising -1, what are we rising now?
1.
+1, but now we're running -2, and do these all line up?
Yep.
This is a linear equation. So it should look like a
Line.
line, and this is looking like a line. And so we can now extend the line through these points and beyond. And of course, use a ruler, because this is not looking very good. Use a straight edge. Let me go get one. Okay, so there it is, nice and straight through those lines, through those points. And we could test other points on this line to make sure that we've created the perfect line, right? I mean, we could try to find some other intersection and make sure that we have the perfect line. It should be down 1 and over 2. So let's see. This is kind of a point right here. This would be at what, 6, -1, 8, 9, 10. Does that make sense? 6 and -1. Would that make this statement true? 6 minus 2, is that 4?
Yes.
It does make the statement true. Okay? So you could test any point on this line if you're very precise about your graphing. All of them will work in this equation. Okay? Real world problems often give us linear equations, and slope-intercept form is a nice way to write those equations. You deposit $100 into a savings account, and then you save $25 per month. Friday we were talking about rates, and rates represent what in our equations? Remember? We've got 2 units here. We've got $25 per month. So what operation do we usually do with a rate?
Multiplication.
And where do we see multiplication in this equation? It's the mx, that's right. So $25 per month is going to represent your, which is slope. It's going to be a slope. It's your rate of change. Slopes are often rates of change. And then B actually is, just like in our previous example, the place where we started. It's a starting point. And so we are not multiplying B to anything else. It's just our starting point. And so if you are a person who's deposited $100 into a savings account, and then you're saving $25 per month, what was your starting point? It was the 100, you see? It didn't change any at all. It just was a starting place. Better than 0. You started with 100, right? So we would put that into this equation. Let's start with the model. Y equals mx plus b. The b is our 100. And the slope is our $25 per month, right? And x and y are just all the possible outcomes that we could have depending on how many months we save, right? So if we save for 1 month, 1 would be input for the x, right? This denominator tells you about the input, doesn't it?
Yeah.
It tells you you're going to input months. So if I was making this equation as a real world example, I might not even use x and y. I might use, since these are months down here, right? I might use m and like total. What total do I have after m months of saving, right? Or s for my saving equals 25m plus 100 or whatever. Okay? Do you understand that it's a linear equation even if we use different variables? It's still a linear equation. Okay? So we're getting to the point of being able to write and graph real world examples, which we could certainly do here. We could graph this. What values may you not want to put in the x here? Lauren? Why not? She says negatives. Why not? Okay, so is it possible to say for negative 4 months? Could you say for negative 12 months, negative a year? It doesn't make sense, does it, in our real world? We don't go back in time. But we could imagine going back in time. If we didn't save for 4 months, we would now be at $0 because they would have withdrawn 25 for every month we were not saving. Strange, okay? Okay, let's talk about an interesting special case or an interesting situation here, parallel lines and slope. So what do you notice is the same? When you're thinking about slope y-intercept form, what do you notice is the same about parallel lines? It's not hard to see, right? What's the same about parallel lines? Riley? Their slope is the same, right? Does everyone agree?
Yep.
What is different, though, about them? Nick? Different, they have different points altogether. They don't share anything in common point-wise, right? But when we're thinking about slope y-intercept, in particular, what do they have different, Jillian? They never intersect, that's true. And Emily?
They have
Different y-intercepts, okay? So we have same slope, but different y-intercepts. So if you were asked whether two lines are parallel, you could use slope y-intercept form. You could put both of their if it was on a graph like this, you would just look at it and say, oh yes, they are, right? But if it was just in the form of an equation, that's not as easy to see unless you have them both in slope y-intercept form, right? If you do, what will you notice about parallel lines in that form? You're going to check their what? We just said it. Parallel lines have the same slope. You're going to look in the equation. Do these two equations both have the same slope, the m? If they do, you know that you've got parallel lines. Okay? So you do not have to graph to confirm you have parallel lines. You simply have to get your equations in slope-intercept form and compare the slopes. Okay? There you go.